Welcome to The Explainer. Today, we're diving under the hood of the Vertica database to figure out what makes it so mind-bogglingly fast for analytics. And let me tell you, it's not just one feature. It's a whole philosophy, a series of really deliberate and honestly kind of radical architectural choices. So what's the secret sauce here? Well, it really all boils down to trade-offs. You see, every database is designed for a specific job. Vertica is purpose-built. It's laser-focused on just one thing: reading and analyzing massive amounts of data at incredible speed. And to get that speed, it does things that are fundamentally different from your traditional database. Okay, so here's how we're going to break this down. We'll start at the very bottom, the absolute foundation, how data is physically put on the disk. From there, we'll see how Vertica finds what it needs and then processes it. Then we'll look at how it keeps itself tuned up. And finally, how all these little decisions pay off in a big way for performance. Let's get right into our first section. Everything, and I mean everything, starts with the single most fundamental difference: columnar storage. This one concept changes the entire game. It's the first major trade-off. So a traditional database stores data just like you'd picture a spreadsheet, right? Row by row. All the info for one employee, their name, address, salary, it's all grouped together. Vertica completely flips this on its head. It takes each column and stores it in its own separate, super optimized file. All the names are in one place, all the salaries in another. And this has an immediate, absolutely massive performance impact. Think about it. If your query is just to find the average salary, Vertica only has to read that one little salary file. It completely ignores the name, address, and department files. Just imagine the huge amount of disk reading it just avoided. And because all the data in a column file is the same type, they're all numbers or all dates, Vertica can get incredibly clever with compression. For a list of repeating city names, it can just store New York once and then say, hey, repeat this 100 times. For a sequence of dates, it can just store the tiny difference between each one. This is a level of compression a normal row-based system can only dream of. So the data is stored super efficiently, but that's really only half the battle, right? How does Vertica find what it needs so quickly without having to just scan everything? Okay, this brings us to a feature that honestly feels a bit like magic. It's called projections. The best way to think of a projection is as a physical copy of your data that's been pre-sorted on the disk to be the perfect, ready-made answer for a question you plan to ask in the future. So for example, you could have one projection of your sales data sorted by date and a totally separate one sorted by region. Now, when a query comes in asking for sales in Europe, the optimizer automatically picks the projection that is already sorted by region. This completely avoids slow, expensive sorting operations when you run the query, which is one of the heaviest things a database can possibly do. And this leads to another really key difference. Instead of using traditional indexes, think of the giant, complex index at the back of a huge textbook that needs constant updating, Vertica uses these incredibly lightweight, in-memory pointers called zone maps. So here's how it works. A query arrives looking for a specific date. Before it even touches the disk, Vertica scans these tiny zone maps that are already sitting in memory. If a file's minimum and maximum dates don't include January 1st, Vertica doesn't even bother reading it. It's just instantly rejected with zero disk I/O. This can literally eliminate 90% or more of the data from ever even being considered. Okay, so we've found the right files without doing a whole lot of work. Now, let's look at how Vertica's engine actually processes that data with incredible speed once it's in memory. Now, this is a really crucial point. Most databases, they decompress data as soon as they read it into memory. Vertica is way smarter. It keeps data compressed as long as it possibly can, even performing operations like filtering on the compressed data itself. It only decompresses the final results it needs to show you. This technique, they call it late materialization, saves a truly enormous amount of CPU and memory. It also uses something pretty cool called vectorized processing. So instead of looping through data one single value at a time, it loads a big block or a vector of thousands of values into the CPU. Then, using modern processor instructions, it processes that entire block all at once. This makes analytical math, like sums and averages, just ridiculously fast compared to row-by-row processing. And the conductor of this whole orchestra is a custom-built query optimizer. You see, for any query, there are a ton of ways to execute it, and some of them are just disastrously slow. The optimizer's entire job is to navigate this complex landscape, to find that one highly efficient path that takes full advantage of everything we've talked about. Okay, so this system is clearly designed for speed right from the start. But, any database can slow down over time as you add more and more data. Well, Vertica has a built-in automated housekeeper to make sure that that doesn't happen. A core concept here is that Vertica's data files are immutable. They're kind of written in stone. They are never changed. When new data comes in, it's always written to new files. This avoids a lot of the fragmentation and maintenance headaches that plague traditional systems that are constantly updating data in place. So how does it manage all these new files? Well, there's a background process called the tuple mover that is constantly working. When you load data, it first goes into these small temporary files. Then, this process wakes up, grabs a whole bunch of them, and merges them down into a single, large, perfectly sorted, and compressed file. This keeps the database in a perpetually optimized state without you having to do anything. So what does this all add up to? Well, when you put all these pieces together, you see a system where every single component, every design choice, is built for one purpose, and one purpose only: blistering analytical performance. Let's just look at a quick side-by-side. Where a traditional database reads data it doesn't even need, Vertica only reads the columns it needs. Where one uses heavy, complex indexes, Vertica uses lightweight zone maps. Where one database has to sort data slowly when you run the query, Vertica uses pre-sorted projections. Each choice is a deliberate trade-off, sacrificing a bit of flexibility in some areas to gain massive speed in others. And this brings us to the final and maybe most crucial thoughts. An architecture that is this finely tuned for reading massive amounts of data is, by its very design, not going to be the best choice for other types of work, like, say, frequent single-row updates. You see, database design is always about trade-offs, and understanding them is the absolute key to choosing the right tool for the right job.